Hi students, welcome to my lectures on chemical reaction engineering. In the today's class, we are going to discuss about with a small example about how to find the volume of a PFR and how to find the volume of a CSTR for a certain conversion of reaction. The other name we can whatever the plot which graphical method we are going through, generally named a Levenspiel plot. Okay, let us apply using this Levenspiel plot, let us find out the volume of the reactors needed for certain conversion. The given example is determine the volume of the reactor which is CSTR and PFR needed for a certain flow rate of 1.5 mole per second. That means a reactor is there, it is PFR and another one is CSTR. The flow rate of reactant A into the reactor is 1.5 mole per second. Given these conditions, the rate and conversion data from a batch reactor is given below. That means whatever the plot we have to generate, the necessary data is provided. This data generally comes from batch reactor, and using this data from the batch reactor means somebody has done the experiment. They have found what is the speed of reaction at 0% conversion, what is the rate of reaction, 10% conversion, what is the rate of reaction, 90% conversion, what is the rate of reaction. We have the data available with us. Generally the data comes from the batch reactor, which is simple to get the rates. Given the data, the conversion versus RA, find the volume of the CSTR and PFR needed for 60% conversion. That means we have some data, right? Using that data, find out the volume of the CSTR and volume of the PFR needed for 60% conversion. Given the molar flow rate 1.5 mole per second. Okay, that means this is the data and this is the scenario. That means there is one CSTR and molar flow rate to the CSTR is 1.5 moles per second. Okay, given this, this flow rate with this data, how can able to find out the volume of the CSTR? Similarly, one side it's a PFR. Given the flow rate 1.5 moles per second, given the conversion and rate data, how to find out the volume of the PFR? Okay, to do this, as you know in my earlier class, you have to plot the graph. Which graph? FA0 by minus RA on y-axis, conversion is on x-axis. Now we have the data of x and minus RA. We know FA0. Okay, then let us find out FA0 by minus RA values. X FA0 by minus RA, that means expression you know minus RA, you know FA0. Find out FA0 by minus RA with all the data values, then you get FA0 by minus RA. Then you plot FA0 by minus RA and y-axis. The conversion is on the x-axis. Connect the line, connect all the dots with a power line. Okay, and yes, now the thing comes. I have the data with me. Now I have to find out the volume of the CSTR at 60% conversion. That means at 0.6, draw a straight line, vertical line. Wherever it meets, draw a horizontal line. Okay, then you have the two areas now. Now one area is under the curve and another area is above the curve. Whenever you have to find out the volume of the CSTR, always you have to below and above the curves. That means A1 plus A2, nothing but area of the rectangle. That means volume of the CSTR is nothing but the area of this rectangle. In similar way, whenever you have to find the area of the plug flow reactor, always you have to take area under the curve. Okay, at 60% conversion, draw a straight line, and A1, which is the area under the curve, only this area is nothing but the volume of the PFR. This is how I want you people to do the exercise. Okay, I am not going to put the values. Given the data, you have to draw this graph, find out for yourself. Okay, it will be an exercise for you. Okay, and looking at this, you can now observe the volume of the PFR, which is A1, always less than the volume of the CSTR, because volume of the CSTR is A1 plus A2, volume of the PFR is A1. So that means whenever you see this kind of curve, increasing curve, that means with respect to conversion, Fa0 Ga minus is increasing. That means whenever you see this kind of curve, always volume of the plug flow reactor less than the volume of the CSTR. Let us see a different scenario where volume of the CSTR is less than the volume of the PFR. Let us meet with that particular lecture. Thank you.